For centuries, humans dreamed of reaching the sky. Today, that dream has become a breathtaking reality. Across the world, cities compete to build higher, creating skylines that seem to challenge the limits of engineering. The skyscraper began with steel frame buildings just over a century ago. Since then, every generation has pushed the limits higher. But before a skyscraper rises, engineers must first understand what lies beneath it, sometimes hundreds of meters underground. The first visible step is excavation, as enormous machines remove thousands of tons of earth to create space for the foundation. Deep foundation piles transfer the enormous weight of the tower into stronger layers of soil and rock beneath the surface. Millions of liters of high-strength concrete can be poured continuously, creating a foundation capable of supporting an entire vertical city. Then the building begins to climb. Steel and concrete rise floor by floor, transforming an empty site into a growing giant. At the heart of many super tall buildings is a massive reinforced concrete core, providing strength and stability against extreme forces. Month after month, the structure grows higher, until the once empty skyline is dominated by a new architectural giant. Every record-breaking tower begins long before construction, with thousands of calculations, simulations, drawings, and engineering decisions. Wind becomes increasingly powerful at great heights, so engineers test models to understand exactly how a tower will behave in extreme conditions. In earthquake-prone regions, engineers design structures that can absorb movement while protecting the building and its occupants. Specially engineered steel provides enormous strength while keeping the structure efficient enough to reach extraordinary heights. Modern skyscrapers also depend on high-performance concrete, capable of carrying immense loads under demanding conditions. As the building rises, tower cranes rise with it, lifting materials hundreds of meters above the ground. Construction becomes a carefully synchronized operation, with different teams working simultaneously across dozens of levels. Finally, thousands of glass panels form the building's outer skin, transforming the raw structure into a recognizable skyscraper. Some super tall towers use enormous damping systems to reduce uncomfortable movement caused by wind and other forces. What appears from the outside to be a single tower is actually a sophisticated system of structures, machines, materials, and technology working together. At extreme heights, elevators become essential. Advanced systems transport people through hundreds of meters in remarkably short periods. Behind the walls lies an enormous electrical network, supplying everything from lighting and elevators to emergency systems. Water must also travel vertically, requiring powerful pumps, storage systems, and carefully engineered distribution networks. Modern skyscrapers are increasingly intelligent, using sensors and automated systems to monitor energy, climate, security, and performance.
At these heights, safety is critical. Advanced fire detection, suppression, smoke control, and evacuation systems protect thousands of occupants.
Once the engineering systems are complete, thousands of workers transform the raw structure into offices, residences, hotels, restaurants, and public spaces. Observation decks offer something few places on Earth can provide: a view of an entire city from hundreds of meters above the ground. Before opening, every major system must be tested, inspected, and certified to ensure the building can operate safely. And after years of planning and construction, the doors finally open, marking the beginning of a new chapter for the city. But among all these towers, one building became the ultimate symbol of vertical ambition: Burj Khalifa. In the early 2000s, Dubai was already transforming rapidly, but its skyline was about to change forever. Architects and engineers envisioned a tower unlike anything the world had ever seen, one designed to redefine the limits of height. Construction began with an enormous operation to prepare the site and establish the foundations of the future landmark. Hundreds of meters of engineering expertise went into the ground, with deep reinforced piles designed to carry the tower's immense weight. The foundation required an extraordinary volume of high-performance concrete delivered through a carefully coordinated, continuous operation. The central structure climbed steadily upward, using advanced construction techniques that allowed the tower to rise floor after floor. Thousands of workers and specialists contributed to the project, operating cranes, assembling structures, installing systems, and maintaining safety. Its exterior was eventually wrapped in thousands of reflective glass panels, creating the shimmering appearance recognized around the world. As construction continued, Burj Khalifa surpassed every previous height record and became the tallest man-made structure ever completed. Inside the tower, visitors encounter a world of luxury, engineering, hospitality, residences, offices, and breathtaking architectural spaces. Its advanced elevator systems allow people to travel rapidly through an enormous vertical distance that would otherwise take hours to climb. Behind the elegance are carefully engineered materials, reinforced concrete, structural steel, aluminum, and high-performance glass. Its stepped design helps disrupt wind forces, allowing the tower to withstand powerful conditions at extreme altitude. Thousands of people can live, work, dine, and experience spectacular views within the vertical world of the tower. Keeping such a giant clean is itself a major engineering challenge. From sunrise to midnight, Burj Khalifa remains active, with offices, residences, attractions, and visitors bringing the tower to life. Its height and engineering achievements established Burj Khalifa as one of the most significant landmarks in modern construction history. Today, the tower is more than a building. It has become one of the defining symbols of Dubai and modern engineering. But the race did not end with Burj Khalifa. Around the world, new towers were already challenging the next generation of records. In Kuala Lumpur, another extraordinary tower rose above the city, Merdeka 118, reaching nearly 679 meters. Its construction required enormous quantities of concrete, steel, glass, and engineering expertise assembled over many years. Its distinctive faceted exterior and sharp spire give Merdeka 118 a unique identity against Kuala Lumpur's skyline. In China, Shanghai Tower rises 632 meters above one of the world's most dynamic cities. Its twisting shape is not merely aesthetic. It was engineered to reduce wind loads acting on the tower. The tower also incorporates energy-efficient systems and sky gardens, demonstrating how height and environmental design can work together. In Saudi Arabia, the Makkah Royal Clock Tower dominates the skyline with its enormous clock faces and distinctive architectural crown. Its gigantic clock mechanism required extraordinary engineering precision to operate reliably at such a monumental scale. In Shenzhen, the Ping An Finance Center rises nearly 600 meters, becoming a powerful symbol of China's modern financial economy. Together, these towers reveal something remarkable. The skyscraper race is no longer limited to one city or one country. The next frontier is even higher. Projects such as Jeddah Tower are designed to push skyscraper construction toward the 1 kilometer mark. Artificial intelligence is beginning to transform design, helping engineers analyze thousands of structural possibilities faster than ever before. Robots could increasingly perform dangerous and repetitive tasks, from welding steel to inspecting structures at extreme heights. Large-scale 3D printing may also change construction by producing complex building components with greater precision and less waste. Future skyscrapers could generate more of their own energy, recycle water, and intelligently control every major building system. By 2050, today's skyline may look completely different, with taller, smarter, greener, and more interconnected vertical cities. But every additional meter creates new problems, from wind and weight to elevators, materials, safety, and the enormous cost of construction. For engineers, the question is no longer simply how high we can build, but how high we can build safely, efficiently, and sustainably. Record-breaking skyscrapers can transform entire districts, attracting investment, tourism, businesses, and new infrastructure. Inside these towers, millions of square meters become workplaces, hotels, residences, restaurants, and commercial spaces that support modern economies.
But behind every record stands a human story. The architects, engineers, workers, technicians, and countless specialists who made the vision possible.
The technologies developed for skyscrapers often push engineering forward, creating knowledge that can influence construction far beyond a single building. These towers have become more than structures. They are landmarks, tourist destinations, national symbols, and visual representations of human ambition. And the construction never truly stops. As one record is broken, another project begins somewhere else, continuing the race toward the sky. Tomorrow's skyscrapers may be cleaner, smarter, more autonomous, and more deeply integrated with the cities around them. From foundations buried deep underground to towers reaching toward the clouds, skyscrapers demonstrate what coordinated human ingenuity can achieve. From the first steel skyscrapers to today's super tall giants, the journey has been one of constant innovation, competition, and extraordinary ambition.
And perhaps the greatest record is not the height of a building, but the human imagination that made reaching the sky possible. The next giant is already waiting on the horizon.